Hi everyone, in this video we continue to look at coterminal and related angles. And in this problem we're told, given A is 3 comma negative 4 and it lies on the terminal arm of angle theta, determine the exact values of the primary trig ratios of theta. So first off, let's go ahead and let's draw this out. So 3 comma negative 4 is, let's see, about there. So let's sketch this out. And so that means that this is 3 comma negative 4. Now, something to think about is that remember how the primary trig ratios are defined. The tangent of an angle theta is the y value divided by the x value. The sine of an angle theta is equivalent to the y value divided by the radius. And the cosine of angle theta is equal to the x value divided by the radius. So we have to figure out, we're given what our x value is and what our y value is. We just need to figure out what this, what the radius of this circle is. So let's call this r. Now here you can tell that we've got a 90 or right angle triangle the way that we've drawn it. If we draw a length that is perpendicular to the x-axis from point 3 comma negative 4, then this distance here would be 4 units, and this distance here would be 3 units. So I know that r is equal to the square root of x squared plus y squared, which is equal to 3 squared plus negative 4 squared, all square rooted. So r is going to be equal to 5. Now that means that the tangent ratio, or tan theta, which is just y over x, we could have actually calculated before. It's minus 4 over 3. The sine of theta is equal to the y value divided by the radius, which is minus 4 over 5. Oh, whoops. And the cosine ratio is equal to the x value divided by the radius, which is 3 over 5. So r is equal to, this radius here is actually equal to 5. Okay, so in the next example it says, given 0.6 comma a lies on the unit circle of the terminal arm of theta, determine the primary trig ratios for angle theta if theta is in quadrant 4. So let's think about how to do this. And I'm just going to clear the circle here. So let's think about what this means. Let's sketch it out. So here you're told that given 0.6 comma a is on the unit circle. So on the unit circle, that means that this is 1 unit, this is 1 unit, this is minus 1, and this is minus 1. So, okay, so 0.6 comma a, it's in quadrant 4. So that means that our angle theta lies in quadrant 4. And we can draw theta that way. Potentially theta could be a negative angle, or theta could be any number of coterminal angles. We actually don't know exactly what theta is, but we're not asked to figure out what theta is. We are just asked to figure out what what the primary trig ratios are for theta. So we don't even really need to draw the angle. We just need to know where its terminal arm is. We know that because this is a unit circle, this is 1 unit, and thus this is 1 unit as well. This point here is 0.6 comma a, and this distance down to the, if I draw a distance down to the x-axis, such that it's perpendicular to the x-axis, this distance should be a. So this distance is a. Now, since a is in quadrant 4, a has to be negative. So I can solve this problem using the I can solve for a using the Pythagorean theorem. I know that first off that x squared plus y squared has to be equal to r squared, and I know that r is equal to 1. So I have that, x is 0.6. So I have that 0.6 squared plus y squared is equal to 1 squared. I can solve this equation. I know that y squared is going to be equal to 1, I should have written 1 squared. 1 minus 0.36, which is 1 minus 0.36 is 0.64. So y squared is equal to 0.64. Now, as you probably remember, this equation has two roots. It has a positive and a negative root. Now, if I were purely solving for a as a distance, then, and I really should have written absolute value of a here, because distances are always magnitudes. But if I were purely solving for y as a distance here, then y would be strictly positive, and I would just take the positive root. But because y actually represents a coordinate, and I know that it's in quadrant 4, I'm only going to take the negative root. So y is equal to the negative root of 0.64. So what that means is that y is equal to negative 0.8, and thus a is equal to negative 0.8. So now we can figure out what the primary trig ratios are. We know that the tangent ratio is, the tangent of theta is going to be the y value, which is negative 0.8, over the x value, which is 0.6. And this, of course, simplifies to negative 4 over 3. The sine ratio, so sine of theta simplifies to, or is the y value divided by the radius, which is negative 0.8. Sometimes we would just want to rewrite this as a fraction, so this would be negative 4/5. And the cosine ratio would be equal to 0.6 over r. And r, since this is a unit circle, r is just 1. So we have that cosine of theta is just 0.6 over 1, which is 0.6. And again, if we want to rewrite this as a fraction, we can write 0.6 as 3 over 5. So the primary trigonometric ratios are negative 4/3, negative 4/5 for sine of theta, and 3/5 for cosine of theta. And again, you can see that the only trig ratio for theta that's positive in the fourth quadrant is the cosine ratio, because the x value is positive, and when you divide the x value by the radius, you get a positive value.